Hello students, welcome to the next part of our chapter motion in a straight line. We are going to discuss the different type of graphs and we will try to analyze or study the nature of the motion from the different type of graphs. First we are starting from the distance time graphs and we will cover different cases for the different distance time graph and then we will move to the displacement time graph. First is the case when a body is in the state of rest. So if a body is in the state of rest, then the distance time graph for the body, it will be a straight line parallel to the time axis, because we know that distance cannot be zero. So the straight line will not be right on the time axis, but it will be slightly above the time axis parallel to the time axis. In this case, the slope of the graph, which is giving us the speed of the body, it will be equal to 0. So if we take any 2 points on the graph A and B, you can see that at both the points the distance covered by the body is d. For A the time is t1, for B the time is t2. So in this case, if we find out the slope is equal to change of the distance d2 minus d1 over t2 minus t1. Now at both the points A and B distance is d, so we have d minus d over t2 minus t1, which is equal to 0. So body is in the stationary state. If the body is in the moving with uniform speed, a body is moving with the uniform speed, in that case the distance time graph is a straight line inclined to the time axis. It is inclined to the time axis, that is, it is making a certain angle theta with the time axis. So in this case, if you want to find out the slope, you have to select any 2 points A and B on the graph, drop perpendicular on the both the axis and note down the value of the distance d1 and time t1. Similarly, from point B, drop the perpendicular on the both the axis, note down the values of time and the distances. In this case, when we move from point A to B, distance covered is equal to d2 minus d1 and time taken is t2 minus t1. So in this case, slope is equal to d2 minus d1 over t2 minus t1, which is giving us the uniform speed of the body. For accelerating body, when a body is moving such that its speed is continuously increasing, in this case the graph will be like this, a curve graph which indicates speeding up of the motion, acceleration is taking place. But if body is undergoing deceleration, in which speed of the body is decreasing with the time, in that case this type of distance time graph, it will be equal to like this. So you can see that here, from this point onwards, say from point O, the graph is bending towards the time, that is, it is almost running parallel to the time axis. So after the point O, when it turns towards the time axis and starts bending towards the time, almost becoming parallel, it shows that body is coming to the stationary state, just as we have seen in the first graph, its speed is decreasing. So this is a deceleration of the body. And in both the cases, if we find out the slope will be variable because of the curved nature. Body will be moving with the non-uniform speed. Infinite speed graph, if we look at the graph which is of this type, parallel to the distance axis, this type of graph is not possible. Reason, we can see that at just a particular instant of the time, the speed increases and increases by a very huge amount. That means body covers huge distance in almost zero time interval, which is equivalent to saying infinite speed of the body. This is not possible. Also, this type of the graph for distance and displacement, it is also not possible. Reason, here you can see that with the time the distance is decreasing. We know that distance can never decrease with the time. Other type of the graph, this type of the graph, it is also not possible. Reason, we know that distance always increases with the time. So if we draw perpendicular on the time axis, concentrate on these 2 points at which this perpendicular meets with the curve at point A and B. This indicates that body at a particular instant of time is present at two different positions. We know that distance can never be zero, it can never decrease. This means that this graph is indicating the position of body, two different position of the body at the same instant of time. So this is also not possible. So these were the distance time graph. Next, displacement time graph for a stationary body. It will be similar to that of the distance time graph. So we have the time over here and the displacement on the y-axis. The graph is again straight line parallel to the time axis. Again, if you find out the slope of the graph, again the slope of the graph, it will be equal to 0. That slope of the graph, it represents the velocity of the body. Just like we have shown for distance time graph, slope is 0. Same way you can show over here for a body which is moving with the constant speed. For a body which is moving with the constant speed, the graph will be a straight line originating from the origin inclined to the time axis. In this case, slope of the graph represents uniform velocity of the body, which you can easily find from the slope, just like we have done for the distance time graph. Accelerated motion of the body. If the motion of the body is accelerated in nature, then the nature of the graph for accelerated motion, it will be like this. Okay, so here the slope of the graph, it will represent non-uniform velocity of the body, okay, which is parabola in the upward direction. It is non-uniform velocity because body is covering unequal distance in equal interval of the time. So if we take, these are the time intervals. So in the first time interval 0 to 1, distance displacement covered is this much, and in the same time interval body is covering this much distance. You can see it has increased, and in the next interval, look at the displacement covered, it is even greater. So unequal displacement, so it is a non-uniform velocity graph, parabola in the upward direction. If it is a decelerated motion, if it is a deaccelerated motion, graph will be looking like this, same as that of the distance time graph for the deaccelerated motion. It is a parabola in the downward direction. Okay, here it is again indicating non-uniform velocity, because just like in the C part it is covering unequal displacement in the equal interval of time, here you can also show that it is unequal displacement in the equal interval of the time. It is for the non-uniform deceleration, that means non-uniform acceleration. But if it is a uniform acceleration, sorry, uniform retardation, for the uniform retardation, the graph will be like a straight line with a negative slope. Graph will be a straight line with a negative slope. So slope is negative and it is indicating uniform retardation. Okay. Last type of graph. If we have a graph like this, this is point A, B, and C. This graph represents the motion of a body which is thrown in the vertically upward direction. We know that when a body is thrown in the vertically upward direction, in the pure vertical motion, its velocity is decreasing because it is going up against the effect of gravity. So part A to B of the body, part A to B of the graph, it represents the vertically upward motion. It is representing the vertically upward motion where body is suffering a uniform retardation equal to acceleration due to gravity, that is minus 9.8 meter per second square. But BC portion of the graph, it represents uniform acceleration when body starts its journey in the downward direction from its highest point, because it is now moving in the direction of the acceleration due to gravity, so its velocity is continuously increasing and it is suffering an acceleration equal to acceleration due to gravity, that is plus 9.8 meter per second square. So these were the different type of distance time and displacement time graphs. Thank you.